Okay, gentlemen, we're going to take a look at function compositions today. So first, we look at let f of x and g of x be two functions with intersecting domains. For all values of x, meaning the input, in the intersection of f and g, or the combinations, there are some rules that they are defined by. So first, if we take f plus g of x, so you have two functions, f and g, and you're taking f plus g of x. Well, that kind of makes sense for me to have f of x plus g of x, so the sum. We also have the difference, f minus g of x, is saying I'm creating a new function that is made up of f of x minus g of x, in that order. I could also have a product which looks like fg of x, similar to the ones above. This is f of x times g of x. Then we also have the quotient f over g of x. So this is all very similar to saying f of x, except we're changing what's in front of it to say that, hey, these two things combined of x. It's just a shortcut. And this is saying f of x over g of x. But remember, g of x cannot be equal to 0. We can never divide by 0. I can do this in reverse for any of these. I'll show it for division. G of x over f of x, provided that f of x in this case, because since that's the denominator, cannot be equal to 0. So these are a couple of the initial first rules. Two more quick ones. I could also have f, it looks like fog. F, like a multiplication symbol that's open, of x. And that means take f, and inside of f, plug in the entire function of g. Or I could have g little open o, kind of like a multiplication symbol, of x, and this means take the g function and plug in the f function. So whatever is listed second is what's being plugged into whatever is listed first. These are the function composition things. The ones we care mostly about are these. Division is pretty interesting because of the division part. And as a side note, I could duplicate equations. So I could say something like g of x. So I could be any, and this would just be g of x times g of x. So it's just a shortcut way to say this in shorter would be this. Okay, but these are the interesting ones, this f little o g. And we write it like this. Just to show a couple brief examples. We're going to do domain in class when I'm there, but domain is pretty important. Domain is pretty important because there's this area, where do they overlap? So we've got to know our initial domains first. But just to start, as a separate example, if I were to say like f is something simple, like let's say f of x is, let's say x squared minus 1. And g of x is, let's say, radical x minus 3. Okay? Two given functions. Given these things, I have these rules up above. If I were to say f and g of x, what would that be? Well, that would be taking the functions I have. There's f. Here's g. And writing them as a sum. X squared plus 1 plus this entire radical. I can't do any combining into the radical, so I would just leave that. Okay, sometimes they combine really nicely, sometimes they don't. If I were to do something like g over f of x, that'd be taking the g function and dividing it by the f function. So most of these you just kind of write in whatever format it tells you. So plus, I put them to plus sign. Can I combine like terms? Sometimes you can. Here you cannot. If I do division, okay, I write them as a division. The interesting ones come when I take f and I plug in g. And I'll start with like f of g of, I don't know, let's go with 8. So first is understand what this means. So this is the same as f of g of 8. So let's first look at g of 8. 8 minus 3. This would give me a radical 5. If I got something that was a perfect square, that'd be great, but I didn't. That's okay. That result gets plugged into the f function. So now I'm taking the radical 5 that I got as a result of plugging in 8, and I plug that result into the f function that's on the outside. So now I get radical 5 squared minus 1. And this gives me 5 minus 1. So this gives me 4. So this is a two-step problem. So the nice thing is that we would say f of g of 8 would give me as a total result that 4. Or you can say f of g of 8 gives me 4. But you do it in two steps. Inside, then outside. Okay, and that's the important part here. So that's just showing it with a number. The nice thing, the interesting part here is I got a radical, and I had a radical in here, and then it went away. So this does affect my domain because we have radical stuff that have restrictions, and then we have non-radical stuff that don't. So just an interesting thing to think about when we do domain next time. I'm going to shrink this and slide this over and show you what we mean with some so the equations. If I were to do, let's see, f of g, sorry, vice versa, g of f of x. That's g of f of x. So if I took this and I said g is radical x minus 3, that's my outside. And what I'm going to plug into that is my inside. X squared minus 1 minus 3. So I take my f function and I replace every x in the g function with the f function. So it's exactly what we did here. This was with numbers. I did this in two steps. First, I looked at g of 8, did the inside, got a result, plugged that into f. But when I'm looking at it without any numbers, g of f, well, let me take f, the inside, and write it inside the function of g everywhere there's an x. So I wrote g on the outside with f in every position. Now this doesn't really simplify too nicely, but I could write this simply as this. And a reminder, this cannot simplify. This does not equal x minus 2. No, no, no. Because this factors into x squared, or x minus 2, x plus 2. Right? We just had a test on factoring. So it's not the same thing twice. They are conjugates. They're not the same thing twice. So no simplifying there. If I go back to what we had over here with the numbers, f of g of x, simpler, f of g of x, we see the same thing that we had with the canceling of the radicals. So here we go. I take f, and everywhere there's an x, I'm going to replace that with g. So here's g, and everywhere there's an x in my original f function, since that's my outside one, g, which is right there, gets plugged in for the x's of f. Oops, sorry. So here I plugged g into the x's over here. And when I did that, here's where we see the canceling of the radical. The squared cancels out the radical. So I just get, as a result, x minus 4. So it's really similar to the one up above, except there is a difference here because since my radical cancels, this affects my domain. So that's why these are the ones we stress the most, and you kind of see that here. Okay, so that's our classwork assignment for today. You have a couple problems down below. First three are plugging in numbers, f of g of 3, 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 and then the opposite, g of f of 3. So you plug in -2 to f, plug that result into g, just like we saw up here. Then you do what we did second up here. So I have a plus, a minus, times 2 divides, and 2 composes. These are a lot, but just to show you there, f. A lot of these are just combining like terms. Good review from the test we just had. Combining like terms, and then this one is the interesting one. Okay, so work on that for the rest of class.